Now we'll have a look at some of the different types of imagery, different types of questions, and work from the Pathways to Healthy Equitable group. Sources of imagery can come from street view or from satellite. Different street view providers are Google Street View, OpenStreetMaps, Flickr Images, Mapillary, Bing. However, in practice, Google Street View is the most commonly used in research. Some of the advantage of Street View is that it broadly corresponds to personal experience of streets and hence potential exposures. In addition, there can be very high coverage in some countries and it is broadly available across different countries. However, typically this image is proprietary. It only covers a small spatial area and has a low temporal resolution, maybe annually at most. The data is typically large and unwieldy, and again, as I mentioned, most is commercial, so there are restricted terms of use. Providers of satellite imagery include Planet, Landsat, or Worldview, and these provide images which are visible. These provide images that include the visible and non-visible spectra and are available in a broad range of resolutions from 30 meters up to 0.3 meters. The advantage of satellite images is that it covers broad and continuous geographic areas. In addition, the relative spatial relationships are less sensitive to the field of view and are consistent across the same data provider typically. There's better availability across the electromagnetic spectrum, of course, and some providers offer better temporal resolution, such as monthly, daily, or even higher. The disadvantages is the coarse spatial resolution in comparison to Street View. In addition, having a top-down view might occlude features of interest, for example, faces of buildings. And the images often provided in large tiles that require extensive pre-processing. There have been huge strides to provide higher resolution satellite imagery. The image on the left shows the Landsat image, which has been around since 1972, versus an aerial image of a baseball game. You can see the coarse resolution captured by this type of satellite imagery. Compare this to Maxar, which has up to 15 centimeter resolution, and as well as Planet, which has up to 50 centimeter resolution. Generally, across different types of images, most comprehensive datasets are available through private providers, and hence there are cost restrictions and there are restrictions in the terms of use. Both forms are unstructured and require a large amount of memory and storage, and also both are snapshots of a given moment, so they're sensitive to particularities in weather, daylight, visibility. And finally, researchers are also beginning to collect primary imagery data as well. So what is our goal with a CNN? Is our goal to classify? Do we need to predict an exposure prediction using regression? Are we trying to identify characteristics of the urban environment or to find certain features? Do we have labels, or are we looking at how could we cluster images in an unsupervised manner in the absence of labels? How can we generate new images which are similar using a generative network? All of this depends on the research question. So let's look at some research. This study, led by Ezra Saul, looks at how well a model trained in one city can transfer predictions on socio-economic demographics to another city. Here we have London income labels absolute ground truth. When we train on London and predict on London, we're able to recover the spatial patterns relatively well. When we start to train on Toronto and predict on London, or train on New York and predict on London, we actually aren't able to capture the predictions as well. Perhaps Los Angeles, we recover the patterns a little bit better. What does this then tell us about urban environments and what poverty or wealth look like in each of those cities and how transferable they are? Does high transferability mean that we can predict economic status at high resolution in cities which don't have census data taken regularly? These are some of the questions that this study raises. Another study led by Ricky Nathwani and Sierra Clark looks at extracting features from street view images collected by Sierra Clark as part of her PhD. From this, the authors were able to hand label these images which are specific to Accra, Ghana, and collect new labels for things such as chocho, which have never been seen before by traditional computer vision algorithms. Here's a map of the different features which were extracted across the metropolitan region within Accra. This work continues to look at how these objects can be used to predict environmental hazards. And I'll also introduce you to my own research, where I use Google Street View images to map citywide perceptions of the urban environment. I built an app for users to decide which image they prefer to walk. From that, we can look at different demographics choices, stratified by groups, such as whether they're from London or not. And I built a deep learning model to predict high and low walkability as ranked by the image pairwise games. From that, I was able to map perceptions of safety, lively, depressing, boring, beauty, wealth, and walkability across London. Okay, thank you so much for listening. I hope this has given you a good introduction to this space. Please now continue on to the Jupyter Notebook to get your hands on our PyTorch CNN model.